Thanks for coming today, and I continue in English. And I give you a quick introduction why we are here. I hope I can answer that question successfully. But I'm supported by two of our technical experts, Ben Mayer and Patti Cetin. They will give you some better, deeper technical overview of what we are doing. I'm responsible for the business in Central Europe for Granta. I'm based in Munich in Germany, and with Granta since 3 years now. I've been here last year already, so some people might have seen me, but I brought a little different presentation today. It's not the same thing. Granta has been founded in 1994 by the two persons over there, Professor Mike Ashby and Professor David Seaborn from the University of Cambridge. So we are a spin-off of the university, and Mike Ashby has developed the technology for structured material selection, which is now results in a product called CS Selector, which you will see this afternoon, as you have heard in the presentations before. But we do more than that. Our main business is material information management, materials data, materials decision support tools. You will see an example later on, and of course the integration in your design process. We are a private held company still with stakeholders from the University of Cambridge and ASM, which is the American Society of Material, which helps us a lot to define the processes. Our idea or our mission is to advance the materials engineering and enable better, greener, safer products through materials information and education. So some of you may know us from the education side as well, where we provide specific material for universities and the materials engineering education. We are the largest organization in this area. We have 120 people globally, but 110 of them are based in Cambridge in the UK, and I'm with Patti in Munich, and we have a few people in the US covering that market. Our growth is significant, profitable, and our customers, at least most of them, are quite happy to work with us. That's very good. And here, for example, in Turkey, we work with Donatus as a local partner, which would be your first address to ask any questions if you have. The key success criteria for Granta was the collaboration with industry companies within two consortia. So we are running two industry consortia with the major aerospace defense industry in the world. Those consortia help us to define the priorities in the process, in the development process. They test our software, they give us feedback, so that everything we do has an industry relevant focus. So you see some of the clients we have globally in various industries. As I said before, most of them are in aerospace defense because that industry requires most of the material data and material traceability. We're also working with a few partners in the world. I've mentioned ASM and the University of Cambridge, but we have also we're working with the top PDM, CAD, CAE vendors for integration aspects. We're working with a number of organizations about materials data, such as we're working close with the Steel Institute in Germany to provide steel information within our system. We're working with others for other type of materials like plastics or powder materials and so on and so forth. So you will see a few examples later. I'll give you a few examples of customers working with us. Eurocopter is one of our larger customers, of course, in Germany and in France. They are looking for a system to manage the composite material data. Apparently, these helicopters are mostly made from composite-based structure, and that's how it started. And then later, Eurocopter became a partner in the EMIT consortium, and the EMIT consortium is focusing on environmental aspects, so all the substances which are not permitted to use anymore and have to be reported within REACH and similar. So the objectives at Eurocopter was really to consolidate the materials, test, and design data in one place. They had the test data, but that was spread around in various Excel files and file systems. And so they brought out everything together at one server. And now they can, of course, improve the traceability. That means if a designer is using a design value, he can always figure out where the value comes from. So you can go back to the test or the statistic analysis, which was the base of this test, of this value. And this is very important because you want to know at any time what the database, where the data comes from you're using in the design process. Another large client, if not the largest one, is Rolls-Royce Aero Engines. Their objective was to provide a gold standard materials information management. That means that there's only one single source in the entire company. There are about 5,000 engineers in Rolls-Royce today working with our system, and they are looking for material data in one source only. So there's no other Excel file allowed anywhere to be used in the design process. One of the issues was really the reuse of test data. As you know, that aero engines use very complex materials, and they have to know a lot about the materials. And the test they're doing is a high temperature fatigue stuff of tests are very, very expensive, in the millions of dollars. And if you do the test twice because you've lost information, then it's really a big loss. And they have addressed this by using a central material information system. And now they have recently spoken at one of our seminars in the UK, and they have reported that they brought down the development process for a new engine by 2 years. So since they're using this system, they've really gained a lot of advantages in the design process. And another example, which is not aerospace, it's a Jaguar Land Rover. I think we would all like to have this car over there, but they're paying us in real money, not in cars, unfortunately. You see that you will have access to the report, the details, while they're using Granta MI as a reference system for the materials. So their internal goal is a zero prototype system, so they only want to buy virtual prototypes, but that means they need very, very good material information, otherwise it's just wrong. So the CAE departments are looking for a system where they can centrally store the fatigue data. That's how it was started, because the fatigue data is very complicated, and so they wanted to store the data and address the needs of the CAE engineers on a better and an easier way. And you see some of the ways to get addressed in the CAE world later in the examples. So why does material information matter at all? So you know, in the various industries we have various different critical questions in the design. So such as, okay, how can we make things lighter? About the environmental footprint? How do I address the thing with conflict minerals or restricted substances? Or cost? They're all questions which you can address by design or by materials or by other means, but materials is a very important part in this environment. So all these questions and the answers to it can be addressed as something like material intelligence. So the more you know about materials, the better your products can become. And the materials intelligence can help to meet engineering challenges on one side. So you can address cost, time to market, whatever, lightweighting, equivalent materials, obsolescence questions, and so on. So that's all your questions you have in a daily life, but they relate also to business. And your company can be successful by building better products, of course. And so we address engineering challenges, but we also address business needs, which is always an important point when it comes to someone has to pay for this. They want to know what it does for the company. So materials information are used in various departments in your company probably. So you have the materials R&D department, which does a lot of testing, the design department, needs a lot of information. They want to know what they're doing. Then we have the production, where there's a lot of Q&A data designed, and they do a lot of testing. They know a lot of information. And then you have the in-service and end-of-life reports and testing and so on and so forth. However, in the current environment many companies live, that information is spread around everywhere. So you find 16 different servers, 500 different PDF documents, but you never find what you really need. So that's they have a lot of islands of information, and there's no systematic access to that data. And that makes things very expensive. It doesn't help you to become quicker and more efficient, and therefore the problem is really that you're wasting time and money by not having access to the material information. We have done a survey recently, and our customers reported that they're going to spend an average of 1 hour per week looking for materials data. That doesn't sound much, but if you have 2,000 engineers and they're spending 1 hour per week, that sums up quite significantly. But more important is the material testing, because it's very expensive in certain ways, or in many ways, and then it's used once and then someone forgets about it, they never find it again, the machine and the hard disk are going to be replaced and the data as well. So this is very important, very cost consuming, and I think there is a solution to it, and this is what we basically do technically as an architecture. We provide a materials data management, materials information management database, and that database is installed within your IT environment. So it's the data is as secure, as safe as your IT environment, and so no one else has access to it. In this database, we collect and we work together to get all the data you have today in this 15 different servers and Excel files into this database. And we can complement this data by, we call it reference data. This is something like MMPDS, the steels reference data, plastic reference data, and so on and so forth. So you have some data measured yourself, and you can complement it with the data which is publicly available as a reference from sources we provide. The idea is everyone who is working with material data in your company accessing the same material information, whether it's someone who is doing kind of analyzing the material behavior, or someone in the design department who wants the data to do a simulation, for example, and so on, or the material specialist who wants to provide new material information or make decisions about new materials, for example. But it's important that everyone is using the same set of information. And that information source is then complemented by tools which makes it easier for the engineers to access the data and learn from it. So such as the CES selector for experts making material decisions, or a material strategy package, we call it. That's something where you can build in your own engineering rules when it comes to materials, so that your designers, if you're a material expert, you will build the rules for your designers so they only do what they're supposed to do and not find everything they want. And of course, I mean, there's specific knowledge about composites, for example, structures, and tools to work with restricted substances type of questions, for example, which is becoming more and more important in the design process, to focus also on compliance issues within the design already. So I give you a little bit more overview about how people in this CAD and CAE world are working with the corporate materials database. So basically, materials information should plug into all your other information systems, whether it's PLM or purchasing or ERP and all these things you're using in your daily life. But material information is everywhere, and it should be collected or should submit information in other systems, so it's all consistent within the organization. However, if we focus a little bit on this area here, we think that the product life cycle, the design life cycle, is different from a materials life cycle. So product is developing itself and it's going through the process, the material is going through its own process. There's a lot of changes when it comes to material. Most of them are like price, availability, supply information. That's changing a lot. But also the restricted substances in ecodata, this is changing a lot. So every piece of it has its own life cycle. However, at a certain point in time, a CAD engineer is selecting a material for his part. And that's good. And the CAE person, sometimes later in the process, is also selecting material. But it's not guaranteed that this, the information, the material information the CAD engineer has is the same than the CAE engineer has. He might ask the player A and he might ask the player B. It's probably similar or quite similar, but it's not the same. So what we try here is that the CAD engineer, if he assigns a material to a part, it's the same information is available in the CAE world, so it's coming from one data sheet, one resource in your organization. So I make sure that the materials specialists, they have approved this material data sheet. And that data sheet goes into the design process, and the CAD engineer assigns the aluminium 6061, and the CAE engineer knows exactly what the 6061 is and how he can use the material information in his CAE model. So that's the idea behind it. How does it work? So this is the process for the materials engineers. They have their raw data, they do all kind of design values and statistical analysis. On the other side, there are engineers, and they have to work with tools. One possibility is there are kind of an export of CAD of ASCII files and data to be used in the subsequent tools. So every tool is understanding an ASCII input for materials. You can do it this way. And for some of the relevant CAD and CAE systems, we have a type of integration. This is a little window, we call it gateway. You will see an example in a few minutes. This gateway connects to the materials database, and you can access that material information and assign it to your parts. And that makes it very easy, very simple, traceable within your CAD or CAE environment to work with the central materials. And the third one is kind of an API where we integrate with all the other systems in your organization if required. So a few examples. So the gateway window is always looking the same. It's exactly the same technology, but plugged into different working environments, such as ANSYS, Abacus CAE, or Alta HyperWorks in the next couple of weeks. That's what we have today. We're working constantly to develop further interfaces, further gateways to other products. In the CAD environment, we currently work with a ProEngineer, or the PTC product, whatever it's called at the moment, Enix, CATIA, Siemens, and also Autodesk Inventor, but it's not shown here. Also here we're working with more systems and address new systems to be supplied to our customers. So that's it for the moment. Any questions?
Thanks, Thomas. And then coffee break.
Coffee break, yeah.